Okay, we're going to be looking at position time graphs here. And whenever you're given a position time graph, these are the typical questions that you might be asked, like find the position, or find the velocity, or find the speed, find the displacement, find the distance. Related to finding the distance, it could be asking you like how far something is. That's the distance. Um, if they ask you like how fast something is, that would be related to the speed. Um, if they ask you to describe the motion, that's also kind of a hard one related to distance, but it's asking you, kind of telling you, it's asking you, which direction is it moving, if it's moving, and how fast it's moving. That's kind of what you're asked to find when it says, describe its motion. All right, so for instance, let's say you're asked to find a position. Like right here, it wants to know the position for number 1 at 20 seconds. Well, that's actually kind of an easy question because this is a position time graph. So at 20 seconds, all I have to do is read it. So here's 20 seconds, go up to here, and well, it looks like it's at 8 meters, and that's the answer. So it's actually kind of an easy one. Velocity. Velocity is also kind of an easy one as long as you can memorize this. Velocity is just simply the slope of the graph at the given time. Like it says from 0 to 10 seconds, so 0 to 10, it wants to know the slope of this line. Now be careful because the slope can be negative. Like for instance over here between 20 and 40 seconds, that slope is negative there. So velocity can be negative. The slope of this line from 0 to 10 seconds, that slope is 0, so it doesn't have any. And that's also related to that other question I told you about of describe the motion. So you could say from 0 to 10 seconds, this is not moving at a position of 5 meters, or you could say the object's at rest at the 5-meter mark in front of the origin for 10 seconds or something like that. That's a description of the motion. This question doesn't ask you for it, but sometimes you'll get some questions that say how fast or what's the speed of the object or something like that. And that's related to velocity, except it's the slope and it has to be positive. So it's always the absolute value of what the slope is. So the speed here of the object from 0 to 10 seconds, that would be 0. The slope between 10 and 20 seconds, here, let's find the slope of that. Let's see, that rises 3 in 10 seconds. From 10 to 20 is 10 seconds. So 3 divided by 10, we get 0.3. And so the velocity there is 0.3 and the speed there is 0.3. But for this last section, let's see, it goes down from 8 down to 0, so that's negative 8 divided by 10, 20 seconds. So from 20 to 40 seconds, it has a velocity of negative 0.4. But that's not what the speed is. The speed is positive 0.4. It's the absolute value of that. Okay. So this question didn't ask you for the speed, I don't think, anywhere, but that's how you'd find it. So these three are kind of easy. Position time graph, just read the graph. Velocity, it's the slope, can be negative. And the speed, I kind of think of the speed as being the steepness of the graph. So how steep it is, it's always positive. Okay, displacement. Sometimes it'll ask you displacement or something like that. And that's related to this question up here of position. So it's actually not too hard to find the displacement. You just have to have this memorized. It's always the final position minus the initial position. Like for instance, here for number 4, so what's the displacement of the object? Well, the final position would be right here, which is at 0. And the initial position would be here at 5. And so the way you calculate that would be, I can't see, here we go, sorry. Would be the final position, which is 0, minus the initial position, which we said was 5. And so the answer is negative 5 meters. So just keep in mind that displacement can actually be negative. Okay. So it's always final position minus initial position. So it's also not that hard to figure that one out. Okay, probably the hardest one is distance, and I think I want to make sure I cover all these other ones first. So the position at 20 seconds, that would be 8. What is the velocity from 0 to 10 seconds? The slope of that line would be 0. What time period is the velocity negative? Well, that would be the slope's negative, so it's between 20 and 40 seconds. Draw the velocity time graph. I think I want to do this one first, and then I want to come up to the hard one of distance. Okay. Well, remember the velocity is just simply the slope. All I have to do is plot all those slopes. So here's a velocity time graph. Notice it looks very similar to the position time graph. I tried to put in these dotted lines. That's at 10 seconds, 20 seconds, 30 seconds, 40 seconds. And the reason why I have some negative numbers here is because I have some negative slopes. So I need to find the slope of this line right here. So the rise over run, that's 0. I need to drop this down again. Sorry about that. Oh, dang it. There we go. And so if I plot that, that would be from here to here, that's 0. And let me make that a little, there we go. So it's 0. Then I have to find the slope from here to here. That would be a rise of 3 in 10 seconds. So on my calculator, I do 3 divided by 10. I get positive 0.3. And so the next line would be up here, positive 0.3. Okay, takes care of that part. And then for this last one, that goes down negative 8, and it goes over 10, 20. So I do negative 8 divided by 20, and I get negative 0.4, I believe, doing that in my head. And I would do that from 20 to 40. So I just think of it as a kind of a plot in the slopes. So the slope here from 0 to 10 is 0. The slope here is 0.3. So between 10 and 20 is 0.3. And then the slope between 20 and 40 is a constant negative 0.6. And so that's my velocity time graph. Or not negative 0.6, negative 0.4. So that's my velocity time graph. It's kind of that simple. All right, so finally the last one we need to do is distance. And I think that one's kind of the hardest one. So the first thing I want to say about distance is a cumulative thing. So if you drive to school 5 miles and then you drive home, eventually you come back home another 5 miles, your distance isn't 0. Your distance is the total amount of distance you traveled, which would be 5 plus 5, which is 10. So I want you to think of an odometer reading here. And the way we're going to figure this, out is we have to look at the position time graph right here. It starts right here, and it stays there for 10 seconds, but then it goes up to 8. So, shoot. So I'm going to draw in here. It goes up like this, and I think I'm going to make that bolder so you can see it. So it goes from here up to here. And then it turns around and it comes all the way back down to here, back to 0. I'm not looking at this part down here really other than to see it's coming back down. I probably should have put arrows on this. So it goes that direction. And then it comes back to 0, over here 0. I'm looking at the position time graph, or position axis. So it goes up 3, and then it comes back 8, so that would be 3 plus 8, and that's 11. So the answer here for the distance is, the distance is not going to let me do this, not cooperating with me here. Sorry. The distance would be 11 meters then. So that is how you figure out what the distance is. Oh my Lord. Okay, so 11 meters is how far it travels. All right, so let's look at another one here. So again, position time graphs, it's really easy to find the position. So number 2, it says at 20 seconds, so that's easy. It's -6. What is the velocity of the object from 30 to 40 seconds? Well, remember, velocity is a slope, and it can be negative. So from 30 to 40 seconds, that slope that's going uphill, that's going to be positive. So it rises 6 in a time of 10 seconds, so that's 0.6. What time period is the velocity negative? Well, that's when the slope's negative. So that's from 0 seconds to 20 seconds. When is it standing still? Well, if it's standing still, that means it's not moving, which means the speed is 0. That means steepness is 0. It also means the velocity is 0. Well, the only time that has a slope of 0, remember slope is velocity, is right here. So from 20 to 30 seconds. The displacement, remember, it's always the final position minus the initial position. Well, the final position would be right here, which is 0. The initial position is right here at 6, so it's 0 minus 6, and that would be -6. The distance, that's the hard one. So remember, for that one, you have to look at that vertical axis. Okay, so I am trying to get this. Boy, it's not cooperating. Sorry. Come on. All right, so we start here and we go all the way down to here. And so that's how far we move, and we stay there for a little bit, and then we come back up to here. So let me go ahead and draw another arrow up to here. So the total distance would be 6 all the way down to -6, so that would be 12 meters that it moves. And then it goes from -6 to 0, so that's another 6 meters. So it's going to be 12 plus 6, and that's 18. So the distance is 18. Whereas the displacement, if you remember again, that was 0 minus 6, that was -6. All right. Draw the velocity time graph. Well, that's just looking at the, oops, let me get rid of that, So I want to find the slopes. So the slope of this first section would be down 12, so it's -12 divided by 20. And I believe that is -0.6. Okay, so -0.6. And that's going to be for a full 20 seconds. And then it's 0 here. Let me make this darker first. And then 0 here for the slope. And then for this last one, it rises 6 in 10 seconds, so that's +0.6. So that's the velocity time graph. So describing the motion. Okay, so I think I would say for describing the motion, it starts at 6 meters and it moves in the backward direction, or you can say negative direction, at 0.6 meters per second, and it does it for 20 seconds. Then it stops for 10 seconds. And then it moves in the positive direction at 0.6 meters per second, and it does that for 10 seconds. So that's describing the motion. It tells you where it starts at. It tells you how fast and in which direction. So -0.6 meters per second. And it tells you for how long, 20 seconds. It stops for 10 seconds. And then it moves in the positive direction at 0.6 meters per second for 10 seconds. Okay. So hopefully that kind of helps you out. I haven't done that last one, but it's kind of it's a similar idea. Okay, for this one, let's see, is there anyone? How far? That's related to distance. So that's asking you, what is the distance? It says, when is it the fastest? That's related to the speed, the steepness. So it's not really slope, it's steepness. So every one of those, think about the speed would be positive. So you're not looking at the slope, you're looking at the absolute value of the slope. So you're looking at where it's the steepest.